It's becoming increasingly clear that electric vehicle uptake has hit an inflection point, and Norway is predicted to see the last internal combustion car sales as soon as next year. And with electric car makers looking for ways to extend range and increase comfort for drivers, a fast-moving opportunity is accelerating towards us. We can see some of the cars of the future in front of us now. My name is Jonathan Gifford, the editor-in-chief of PV Magazine Global, and welcome to this PV on Wheels session of Roundtables Europe, where we're going to investigate the opportunity being presented by solar electric vehicles of all classes and vehicle-integrated photovoltaics, or VIPV. Coming up, we're going to hear from Emanuele Cornagliotti from the Netherlands-based SEV producer Lightyear, which is introducing its Lightyear Zero into European marketplaces. Robert Händel, the CEO and founder of OPES Solutions, will share how his company has driven VIPV modules into the market to become the world's largest supplier of the technology. And Martin Heinrich from the Fraunhofer ESA on the Institute's work in developing VIPV technology while collaborating with some of the world's leading car makers like Mercedes. But first, while SEVs might seem like science fiction to some, the history of solar integration into vehicles is a surprisingly long one. And some of the lessons learned about the earliest proof of concept projects can help inform how we think about SEVs today. Webasto is a supplier to the auto industry, and Rupert Kogler has been leading the company's work in integrating solar into car components for more than 20 years. Rupert, welcome to Roundtables Europe.
Hello together. Hello, Jonathan. Thank you for the invitation.
It's a great pleasure, and it's great to see you here. Now, tell us about these early Webasto projects in integrating photovoltaics into cars.
Yeah. It's for Webasto not new to integrate PV in cars, so we have started this business in the year 1989, so it's over 30 years ago, where we started with Audi together to get the first 40-watt peak solar roof system into the automotive industry.
Okay, well, and this Audi project then, what were the kind of aims for the project when you were going into it?
The focus was on comfort, increasing the comfort for the passenger, and it's still a very interesting feature functionality. So using the sun energy for cooling the interior, and this worked perfectly and was sold to over 300,000 cars.
Okay, and by increasing comfort, you mean that because the PV could power the car's cooling system, that it could, they can just run it for longer, is that right?
Yes, so we directed the solar energy directly to the HVAC blower, and during parking, the sun was delivering the energy and it was directly to the blower, which was ventilating the interior and decreased the soaking by around 50%, so it's a huge comfort increasement.
Okay, and we also know in very hot environments, I come from one myself in Australia, that it can also cause some kind of degradation within the car materials. Was that also tested as a part of this early Webasto and Audi project?
Yeah, this was also a measure to install that system. So what we have found during the first testing, so my colleagues 30 years ago, was that the material was not such loaded by high temperatures, and they realized that the degradation of the plastics in the interior was kind of stabilized.
Okay, so it's actually results in a longer-lived car in hot climates.
Yeah, definitely. It's amazing what they have found when you're kind of decreasing the interior temperature by around 20 to 30 Kelvin. Plastics stays much longer.
Okay. Well, Rupert, please do stick around for our panel discussion a little bit later. But that's a very interesting snapshot, I think, into the early days of solar integration into vehicles. Thank you for joining our roundtable, Rupert Kogler from Webasto. Well, when looking at the opportunities that SEVs and VIPV can present to the solar industry, there may be more there than what first meets the eye. Torsten Brammer is co-founder and CEO of PV characterization equipment provider Wavelabs, and having introduced LEDs to PV cell flashing, he's no stranger himself to step change technologies. Torsten, welcome to Roundtables Europe.
Hi, Jonathan. Thanks a lot for hosting this roundtable.
Well, it's a great pleasure, and it's really nice to speak to you, as always, Torsten. Well, first of all, congratulations are in order. I understand just last week you picked up an award that was handed down by the German Federal Minister for Economic Affairs and Climate Protection, Robert Habeck. What can you tell me about this award?
Yeah, so our products measure the most important parameter in solar, and that's the efficiency. So how well does the solar module convert the sunlight into electricity? And in the good old days, solar cells could absorb light only from the front side, but modern solar cells, they absorb sunlight also through the rear side. And so that was the challenge in this project, that we developed an extension to our baseline product to measure also the efficiency for the rear side of a solar module. Yeah, and Wavelabs, we are a 100-people company based in Germany, and I would say we are the pioneers and leaders in LED solar simulation. So, as I said, we build artificial suns by using LEDs with different colors, and our customers are mainly solar cell and solar module producers, but also research institutes.
Okay, well, thank you for that, Torsten, and congratulations once again. Well, let's turn our focus onto SEVs and VIPV. So many acronyms always in the solar industry. Now, how would you describe the advantages then of integrating solar into electric vehicles? Because we know there's a huge amount of interest in EVs right at the moment.
Yeah, I mean, there's two main obvious advantages. One is simply the sun recharges the battery as you drive. So the sun helps to extend the range of an electric vehicle. And secondly, you need to go to the petrol station, or well, in this case, it's not petrol, need to recharge the car less frequent, right? So it adds comfort to using an electric vehicle.
Okay, and actually we heard that with petrol vehicles, it does also increase comfort as well. But you've been in the solar industry for 30 years now, which is quite a stretch, and congratulations for lasting so long. What makes you excited about the opportunity presented by solar electric vehicles, from the solar industry standpoint?
Yeah. I mean, first of all, we see here the fusion of two mega trends. One is solar electricity is now the cheapest source of electricity. And secondly, electric vehicles are on the rise. And those two now come together to form this new mega trend. We're still at an early stage, though. So beyond the two obvious advantages I mentioned, that there's a lot more advantages. So, for example, the soft costs of sales are reduced to a single click in your car configuration software. Nowadays, the cost for a solar module in the total system, particularly for small systems, is pretty marginal. So there's lots of extra costs, and this is not the case for solar in electric vehicles. So, and secondly, you have a streamlined installation, right? You integrate the solar module in a factory, not on a roof, which requires a lot of customization. You don't need an inverter that usually adds costs to your solar system. You don't need extra storage, right? Because the electric vehicle runs on a battery. And there's no extra cost for the hookup to the grid. And of course, you can self-consume your cheaply produced solar electricity directly yourself without any obstacles in between you and the grid or whatever.
So kind of the way that you're talking about it is that the SEV, it broadens the number of solar consumers. If you think about it from the other angle, if you're a solar consumer, all of a sudden packaging PV into your car just becomes almost a trivial process.
Yeah, exactly. So it's a standardized component. You do the engineering once for a few hundred thousands or millions of cars, and then you've done the engineering, right? And for a solar system, it requires usually a lot of customization, and the sales process, as I mentioned, is also so the customization and the sales process adds a lot of extra cost, and for solar electric vehicle, that just disappears.
Great. So we could actually see a huge number of more solar consumers because just by virtue of their electric vehicle. But it's not all going to be straightforward, right? You know, one of the beautiful things about PV is that it's a solid state device. It just sits there. A car is a very different thing. It's moving, it's out in the elements at all times. And of course, safety is a huge concern. So what do you see as being the big challenges?
Yeah, with so many advantages, there are, of course, a few challenges, which I think are purely engineering, not like fundamental issues. But of course, the solar roof is not always has not always the perfect position to absorb most of the sunlight. So we need to expect a pretty average kilowatt hour per kilowatt ratio. And of course, there will be partial shading as you park your car in a high-rise area. There's trees, alleys, etc. So that can cause hot spots. The solar roof sees a lot of heavy mechanical exposure from the road, the bumpy road, or so that adds extra load to the solar module. And also the high module temperature, right? So because there's no ventilation from the back, and that adds extra temperature to the solar module, which is not the case for freestanding solar modules.
Yeah.
And all these reasons, are the reasons why many solar technologists are skeptical about the fusion of solar and mobility. Yeah.
Yeah, but you said, but you think these are engineering challenges, that these can be overcome, right?
Yeah, exactly. So that just means extra headache for the engineers in the industry, right? But I'm sure this has been solved and will improve with time. Yeah,
Okay.
definitely.
Well, you are in a characterization or a testing equipment provider, a flasher provider. What role then is there for testing that you see in the future as SEVs or VIPV products become more widespread?
Yeah, so we expect various stakeholders to drive demand for quality assurance for solar electric vehicles. So think of the car insurance company. So they need to understand what is the safety level of this new electrical component, and does the safety level change over time? Or just think of, I usually use second-hand cars, right? So imagine you buy a second-hand solar electric vehicle. Usually you just jump in the car, you take it for a short trip, and then you know the engine works and the acceleration is fine. Okay, should be good, right? So you buy the car. So with the solar module, it's quiet and it doesn't move, right? So me as a buyer, I would like to understand and have a quick check. Does the solar roof actually still work, right? So how do we do quality insurance inside a car shop or workshop, right? So this is where I would go to have a kind of an audit, and we need the tools to do that cheaply and with a significant result.
Well, you make tools. How far away are they?
Yeah, so we entered the industry, let's say 2 years ago, and we've been working with 3 partners, commercial partners, industrial partners in this sector. So we see great potential and for our electroluminescence and infrared imaging technology, but of course also with our core product, the LED sun simulator, and they all can be used in end-of-line testing. So as you produce the solar component or the full solar electric car, or then also on-site in small workshops, right? They need some sort of a tool can't be too expensive to check if the solar still works. And we see the imaging technology here as the way to go.
And it will be some combination of sun simulator, EL, and UV as well, or no? What was the other component?
Infrared imaging.
Infrared,
so
okay.
This helps to detect hot spots, right? So for example, if you had an accident, you might get cracks, and hot spots can be hot, and you don't want that. And so this could be detected with this technology.
Okay, and you might not only be testing, we were speaking about Webasto and they had the solar sunroof way back in the day, but you might also be testing kind of unusual shapes as well, right? So it might be the hood or the trunk in the back or even the panels on the side.
Yeah, exactly. So what we see right now, the component is manufactured individually, and all those individual components see end-of-line testing. And and one of the challenges here is that you usually have bent surfaces, 3D bent surfaces, so that adds some complexity to measure the power output accurately. Standard solar modules are flat, and this is what the standard also for measurement of those solar modules is designed for. So so this just shows that also the certification bodies need to get involved so that we have a global standard for these solar components.
Okay, well, there is a long way to go, but the potential is absolutely enormous. And Torsten Brammer, the CEO of Wavelabs, it's good to hear that smart people like yourself and your team are thinking about some solutions right now. Thank you very much for joining Roundtables Europe. Well, the opportunities for SEVs for the solar industry are certainly enormous. But undoubtedly, there will be challenges, as Torsten and I were just discussing. Some of them we will foresee, but some of them are no doubt going to come up a little bit unexpectedly. So now let's talk through some of these challenges with the companies that are actually developing these SEVs and solutions incorporating photovoltaics into the mobility sector. I'd like to welcome Emanuele Cornagliotti, the lead solar engineer for Lightyear, Robert Händel, the CEO and founder of OPES Solutions, Martin Heinrich, head of group encapsulation and integration from Fraunhofer ESA, and Rupert Kogler. Welcome back from Webasto Group. Thank you, gentlemen, very much for your time today. Okay, Emanuele. First of all, Lightyear itself, I think we had an image earlier on in this session. It looks like it's a pretty impressive vehicle. You are now bringing the Lightyear 0 to European marketplaces. Just how critical is the solar solution to the vehicle itself?
Well, of course it is very important, but I dare to say that the Lightyear 0 project is actually about building a very high efficient electric vehicle. So that's actually the core of the project. And also to develop, let's say, the technologies, not only solar, but for instance, the in-wheel motors that will enable high efficient electric vehicles to be diffused in the future. So we in Lightyear actually have really a target. It's our mission to develop high efficient, and I think there are very, very important reasons for that. And well, first of all, we have one reason which is basically technological, right? So and this reason is why actually it's much more important to develop high efficiency for electric vehicles than for internal combustion engine vehicles. So you have to think like that one liter of gasoline contains an embedded energy of 10 kilowatt hours. So if you have a car with 60 kilowatt hours battery, so actually you have to do the job equivalent with the equivalent of 6 liters of gasoline. So of course you have to be very efficient, and a big help comes from the electric motors, which are inherently more efficient than combustion engine, but you have to keep on pushing that. And the second reason is basically environmental. I mean, we're going to switch to electric vehicles. We're going to actually slash our emission compared to internal combustion engine by at least 50%. But that's not enough. Probably number of cars will keep on increasing. So actually, we have to strive for highest efficiency.
Yeah.
And the third reason is about the convenience, and convenience for the customer, but also convenience in a more general sense, because reducing cost for let's say also the installation of infrastructure, which is going to be a massive cost when we're going to be switching completely to electric vehicles. So there are basically three main reasons, right? And of course, when you have like a very high efficient vehicle, then adding solar to it is actually a no-brainer. So it's a little bit bizarre, but in a way, like if you could, let's say, if the convenience of adding solar could be a mathematical function, it would not be linear with the efficiency of the vehicle, but there would be a kind of a tipping point above which the convenience for the customer becomes enormous. And let's say this tipping point is when actually the energy you harness every day is more than you can use for actually your daily commute.
Of course, yeah, that makes sense, right? A highly efficient car, all of a sudden each kilowatt hour that you can produce on the car itself becomes more valuable. Rupert, like in light of that kind of equation from Webasto's side, you supply a heap of car manufacturers. How commonplace are you seeing that they're considering solar integration in their electric vehicles? Ooh, just Rupert, one moment. Can you start again? We lost your sound at the start, but you're back.
Can you hear me now?
Perfect.
Perfect. So let me describe as following. The first generation of electric cars are now on the road, and the OEMs are looking for increasing their efficiency. It will be a game of efficiency. Who will win this game at the end of the day? And as already explained by Lightyear, that it's a circle of innovation have started with this new source of energy, which is supporting your everyday driving. And when you are able to compensate with, I call it wireless charging by the solar roof, your commuting path, then you don't have to circle around looking for a charging station. And that's really convenience, yeah. And besides the comfort factor of reducing the temperature, so it's really an amazing outlook to the future, and I'm looking forward to see also the Lightyear in reality. Yeah.
I think you've got an invitation to Munich, Emanuele. Now, wireless charging, I like that idea very, very much. But of course, we're talking about passenger cars here, but there's a lot more vehicles on the road than simply passenger cars. Robert Händel from OPES Solutions, you've been supplying all sorts of different mobility segments with specialized VIPV products, solar modules. How much are we seeing demand from these other vehicle segments, looking elsewhere than the sedan or the sports car or the standard family car that we know so well?
Thank you, Jonathan. There's of course a broad range of vehicles where solar adds different values. I mean, one example of this is, I think 4 or 5 years ago, I saw first time this share bikes, solar share bikes in Shanghai, and they came out of nowhere. And meanwhile, we are market leader in the segment to provide the panels, and this is a sector with several million of products every year. So that was something where the solar has a value add just to give messages to the cloud and control the lock when you rent them with a smartphone. But if you go one vehicle bigger, let's say heavy-duty cargo bikes, we have a cooperation with Urban Mobility, and they have additional time of 45 minutes for their tours, and that they can take into the calculation in their business model. So they can make other tours, make a replanning, and then we can see that solar is already commercial viable for this specific case. So very often it starts with a pilot project with many sensors where you collect these data. And then of course, when you go bigger vehicles like buses, trucks and so forth, It can be range, it can be like a tail lift of a truck that you power extra, or in the caravan sector, the days of autonomy. And we learn always from our customers in the project how they operate it and how it goes, where it can really bring which benefit. And in many of these vehicles, we are already commercially very feasible today.
Mm-hmm. So you're seeing that they're coming to you with use cases, and that's kind of opening your eyes as well. Oh, so the number of use cases are growing.
Yes, I mean, like Steve Jobs said once, you can connect the dots laterwards, but not in advance. So that's how we have to move in this new industry.
Absolutely. Okay. Yeah, that's a nice message. Rupert, you know, when we're talking about on the road, then we're talking about automotive rated. There's a whole different level of safety required than in the standard PV industry that many of us know. What are those requirements, or how challenging are those requirements, particularly in terms of things like impact or damage that could occur?
So with that kind of huge PV applications within the car, you have to take care about that safety issue. And let's say there's one keyword, it's the hazard and risk analysis, which is kind of the very beginning of integrating new features and realizing functionalities into the cars. And this is one of the biggest challenges for us to get the complete system on a safe path of integration.
Okay, and what is the key then? Like, is there one key to a safe way to integrate solar into mobility? What are the things you have to pay attention to? Robert, perhaps over to you. You've been making modules that are going to be out in the field and moving about. What do you feel needs to be addressed?
Yeah, I mean, from our view, we are a customized OEM factory or manufacturer for customized modules, and built there like a manufacturing platform that is very different from standard module producing. So we are very much used for different industries and product to go from drawing a prototype to a pilot production and then into mass production, and also build automation equipment for this along the road, for GPS trackers, for parking meters. I mean, there's many small modules that is on scale already, and we bring this experience into the vehicle industry and look what is the vehicle industry really needed. And we noticed it's also not one automotive industry, because we have different requirements on a motor lid of a car. There's impact testing and all this, while on a caravan you have pretty little regulations. And we have so far developed like two products. Like one is a very thin flexible model to glue or apply on truck roofs or buses, and then a drop-in replacement, a lightweight PET sandwich that can be box building already in cargo vehicles, and still in pilot phase now, and R&D is actually real 3D elements that can then become part of vehicles. So we see this like different products will evolve for this sector. And I mean, it's still an ongoing process.
Okay. Thank you, Robert. Well, Martin, you've been waiting very patiently. Martin Heinrich from Fraunhofer ESA. What are you seeing then? You're part of the Encapsulation group. I imagine you've got a lot of insights into some of the challenges that present in vehicle integration, but also some of the technologies that can really help get over those challenges. What do you see as being some of the most promising?
Well, yeah, it really depends on the different applications. Yeah, so for cars, I would say, or for roof of the cars especially, you have the glass setup. Yeah, it's very similar to the panorama roof of a conventional panorama roof of a vehicle, and you can just integrate the solar cells in there quite easily and quite straightforwardly. So I think that's the way to go there, to go forward there. However, for other applications, like for example trucks, you need to have like some lightweight approach, and there are different module technologies explored in the field, but it's really not decided yet which technology really fits and ticks all the boxes, like mechanical robustness, hail resistance, and also long-term durability in terms of thermal mechanical loads.
Okay, what about in terms of appearance then? I understand there's some kind of new sputtering technologies that will be able to give a really uniform appearance over the surface of the vehicle, which of course, when you're talking about high-end cars, that's what the consumer's demanding.
Yeah. So of course, for trucks, coming back to that example, it's not really necessary to have something very nice and appealing to the end customer, because it's really mostly about efficiency and cost savings for trucks. But for cars, especially there, the visual appearance is very, very important for them. And in that case, we have developed like a color coating. It's called morphocolor coating, which offers a very bright and brilliant color, which effectively hides the solar cell behind it. You can only see it when you go very close to this to the roof or to the module, and it only has very, very little losses, like around 7% losses for spectral colors. So that could be one option, but I mean, I've seen the Lightyear 1 and the Lightyear 0. Yeah, that's also a really nice way to play around with the appearance of the solar cells. So that's also quite nice.
Cool. Well, I think that Emanuele, please jump in. Talk to us about appearance, but also I understand Lightyear 0, in developing that, you've also developed a technology to have curved to curve cells in a way that doesn't, of course, impact their power output.
Yeah, well, we work with crystalline silicon solar cells, which have a certain capability to bend. Of course, they have some limits, but these are actually, which also depends on the thickness of the wafers that are used. But let's say that for the curvature that we use, and even if we would use higher curvature that we are using, the crystalline silicon solar cell can actually do the job in that sense. And regarding the aesthetics, yes, I think it would be very nice to be able to customize the color, but also a black uniform appearance is very well accepted as long as it's of course uniform, because of course you have a black roof and you can go pretty much with any other side body color as well. So that also works quite well in a way. Because of the nice color contrast.
Okay.
But
yeah, and then also the curvature to kind of meet the challenges of the curved spaces, because as you were saying, efficiency is key. So you need aerodynamics also to be very, very good also.
yeah, well, definitely, aerodynamic is a bit the key of the whole Lightyear 0 project, I would say. Having an aerodynamic car actually let you enter in a kind of virtuous circle, right? Because you have less energy loss, and then of course you can also employ a smaller battery, which in turn leads to a reduced weight, which then gives you even less consumption. And the solar is the same. Solar allows you to have also a smaller battery eventually, and therefore you also have a lower weight and so at a certain moment, efficient design, it's really a virtuous circle there. But of course, yes, double curved is important for aerodynamic performance. So we have been developing actually the manufacturing process to manufacture this double curved solar arrays internally. And we are actually setting up the manufacturing line, which will be operative at the end of this year with a few megawatt capacity at the beginning, but with the plan to potentially expand that in the course of 2022.
Yeah, okay. Megawatt, but very much early stages for the technology. Martin, looking at weight then, you know, we're talking about integration of solar into the vehicles running. Of course, low voltage is different to high voltage. In the earlier example we heard from Rupert, the solar was very much in the low voltage system of the car. How big a step of that is that to then integrate the PV into, you know, the electric drive train of the vehicle?
Yeah, yeah. As Rupert also earlier mentioned, the safety concerns regarding PV integration. Yeah, and you want to avoid integrating the PV panels into the high voltage train at all costs, because there's a potentially high voltage explored there on the roof of the vehicle. So that can really lead to some potential issues and hazards. So the easiest way to integrate it is into the low voltage train. However, if the module offers such a high power, for example, 300, 400 or 500 watt or more, you cannot go there anymore, because you don't know what to do with all this energy. Yeah, you can only cool down the vehicle so much until you are freeze in the vehicle with all this excessive energy. So what you need to do there, and especially for truck applications where you have like a large roof area, you need to go into the high voltage train, and there you need to look at safety mechanisms which are reliable and which can still work even in the case of a crash of the vehicle. In a research project, we developed a mechanism which disconnects the modules from the high voltage powertrain in a safety manner. And this vehicle, this test vehicle, is currently driving around in Freiburg and road legal, and also confirmed by DEKA or TÜV, so that we can drive around with it.
Okay, so there are workarounds. There are solutions that are being developed. Robert, you've worked a lot with trucking in developing modules, specialized modules for that segment. You know, long distance trucking in particular is often talked of as one of the very hard areas of our economy, of transportation, in terms of electrifying and decarbonizing. You know, what potential do you see there as a module supplier to the space to integrate solar and provide some more range support for trucking, perhaps not long distance, but trucking of all shapes and sizes?
All right. Yeah, I think if you look on a timeline, the first vehicles where we move now are actually diesel-driven trucks, where we can apply solar. We have the cooperation on system side with BOS, where we can, with solar, already save fuel over the year. So this is with a truck roof size, about 1,900 to 2,500 liter of diesel that you can save on an annual basis. And this was already commercial feasible like half a year ago, and now with the fuel prices, even more. So that's something where, of course, it's a first mover step for us in this segment. You have, of course, also the smaller light electric trucks, the LE7 trucks, like, for example, Centro has one of this, and there with a solar cargo box, we can already reach 30 to 40 kilometers driven by solar. That's their range, so we can fully decarbonize already on the last mile sector. It's, of course, much smaller than the big trucks, but also very feasible. And overall, if we count all truck roofs together, this becomes really a very big area. And looking at the global perspective, this is an area where solar doesn't compete with agriculture or other areas. And now when we're going to put solar everywhere to fill our energy needs, we should use the truck roofs, because we have then going forward also directly batteries there where we can put it and not need to take this energy from the grid.
Yeah, indeed. I can imagine along the Autobahn, lots of trucks there charging overnight. Martin, and what work is Fraunhofer doing beyond the project that you just spoke to me about in terms of trucking and solar integration?
Yeah, we do work together with some vehicle manufacturers to look and explore the potential of the technology. So one example, which is also publicly available, is the EQXX, which you mentioned at the beginning, where we manufactured the roof of the vehicle with solar cell integration, and it actually supports in this case the low voltage train, and so they have this huge screen in the vehicle, and it powers the screen, for example, and the entertainment system.
Okay, and Rupert, then you know, that EQXX, that's the Mercedes project. Kind of coming back to the car makers, then how aware are you of them working or really looking for that high voltage train integration of the solar components in SEVs or in just EVs with some PV?
Also, referring to Martin, when the solar roof systems are getting more powerful, yeah, we have started with 40 watt peak. Now we are going in the direction of beyond 300 watt peak. We have to connect to the high voltage battery, and therefore we need the electronics to overcome and to get the energy into the battery. Otherwise, we would lose the energy, and the car is most of the time parked and not driven, and that's the time where we are harvesting the free energy.
So then it's inevitable. We have to really overcome this step. Is that what you're saying?
Yes, definitely, and we are already working to get such electronics on the market. Yeah.
Okay, well, I think that's an exciting message to take away. I think the world of solar electric vehicles, as pioneered by Lightyear, it's great to have you on our panel, Emanuele, is a very exciting one, but also VIPV across all different types of vehicle types, including, or vehicle classes, including trucks, including things like cargo bikes, all sorts of electric mobility solutions. Thank you all very much, gentlemen, for your time. Emanuele Cornagliotti from Lightyear, Robert Händel from OPES Solutions, Heinrich from Fraunhofer ESA, and Rupert Kogler from Webasto Group. Thank you very much, gentlemen. And thank you very much for your attention today. And of course, thank you to our partners here at Roundtables Europe 2022. We are very lucky to have such an amazing group of platinum partners, our lead partner, and of course, a large number of gold partners. So particular thanks to our lead partner, Trina Solar, platinum partners, Axpo, Jinko Solar, Longi, Seraphim Solar, Smart Energy, Solar Edge, Studer Cables, and Wavelabs. Thank you very much for your support and for being a part of our Roundtables Europe event here today. But of course, we've got another whole day of activity ready for you tomorrow. And there are lots of other opportunities to keep this discussion going. And you can join others in a range of languages right here on this platform. We really have many European languages covered, and we want you to be a part of the discussion. You can join group discussions in French, Spanish, and English. Tristan Rayner will continue the discussion about SEVs. That's PV Magazine editor Tristan Rayner, with Martin Heinrich from Fraunhofer. So if you want to learn more about that, please join that session. If you speak Spanish, Pilar Sanchez and Emiliano Bellini will be talking with two Spanish solar developers about challenges in terms of grid access, grid connection in the Spanish market, which is growing very fast and looking very promising. If you're French, our French team, PV Magazine France team, will be in conversation with Nicolas Schuller from Everrose to talk about agri-PV, which is also a little preview to one of our sessions tomorrow. We'll be talking about agri-PV in the first session of the day, and I look forward to welcoming you to that session. Other activities going on tomorrow morning at 9 a.m. in German. Cornelia Lichner will be discussing floating PV. The name of the session is Sweet or Salty, and that's with Syn Power and Erdgas Südwest. And if policy is your area of interest, Beatrice Santos will be discussing with experts from Aurora Energy and the Climate Action Network the key discussion, switching gas off, power to the roof. So there's a hell of a lot going on here at our Roundtables Europe program. And of course, join me here on the main stage. I'm Jonathan Gifford. Thank you for joining us for day one of Roundtables Europe 2022.